Today we'll be continuing our work with Chapter 6 on normal probability distributions. We'll be specifically looking at Section 6.5 on assessing normality. We will be skipping Section 6.6 on normal and approximations to binomials. Normal as an approximation to binomials. Okay, so in this section, we're going to be looking at how do you determine if your distribution is a normal distribution, if those requirements are being met. Because if you remember in the previous section, one of the requirements for using the central limit theorem was that your population was normally distributed, but you don't know that. I mean, not in real life, nobody's sitting there telling you it's normally distributed. You have to figure that out. So some of the resources we're going to be using are just a visual inspection of the histogram. So back in chapter 2, we talked about histograms, making sure it's roughly bell-shaped. The second is to identify any outliers. And then the third, the one we're going to focus on more in this section, is constructing a normal quantile plot. So we did talk briefly about these before, just if they were already provided to you, how to determine it. Now we're going to look at how you generate the actual normal quantile plot. Okay, so a normal quantile plot, which is also referred to as a normal probability plot, is a graph of points where each x value is from the original set of sample data, and the y value is the corresponding z-score that's expected from the standard normal distribution. So when we look at these normal quantile plots, we're going to be able to draw a conclusion about whether your population is normally distributed or not. So just to kind of recap, when you're constructing a histogram, if it isn't bell-shaped, then you're going to be able to conclude that it doesn't have a normal distribution. We talked about outliers in chapter 3 and said that any outlier is if something's above the third quartile by an amount greater than 1.5 times the inner quartile range, then it would be considered an outlier. And most of you, found your outliers on your data set during a StatCrunch lab that we did. So here, if we look, it would be an outlier if it's below the first quartile by an amount greater than 1.5 times the inner quartile range. And we know that the inner quartile range is the third quartile minus the first quartile. Okay, so if we're looking at the normal quantile plot, we're going to actually not be generating that by hand. We're just going to use the calculator and the StatCrunch to generate our normal quantile plots for us. Okay, so if we look at the normal quantile plots, what we have is that the normal distribution, a population distribution, is normal if the pattern of the points is reasonably close to a straight line and the points do not show some kind of systematic pattern that's not a straight line. So if you see some kind of curvature that's very round and curvy, then that, even though it might hug pretty close to a straight line, if it's got that curvature to it, then it's not going to be a normal distribution. Okay. So it's not a normal distribution if the points do not lie reasonably close to a straight line, and also if the points show some kind of systematic pattern that's not a straight line pattern. Okay, so I want to show you some examples. This would be one of a normal distribution. So if I look at these two, this is the histogram and this is a normal quantile plot. So it's always kind of good to look at them together and see what they collectively tell us. This one is approximately normally distributed because when you look at it, it's basically symmetrical, and therefore we could say it's approximately normally distributed. If you're looking here at the normal quantile plot, it does line up very close to a straight line except for these first and last couple values, and that's going to be fairly typical for a data set. So as long as the majority of it is lining up in a straight line, don't worry too much about these couple first and last values here because they could be outliers even. Okay, the uniform example, if we have a uniform distribution, which we know is the rectangular shaped distribution, if you look at the normal quantile plot for this one, what we see here is we see this curvature. So at first glance, it looks like it lines up very close to that straight line, but when we look a little closer, we see that it does have curvature to it and that systematic pattern, and therefore it would not be a normally distributed population. Okay, so a skewed example, if our histogram looks something like this, clearly this has a right skew to it, and this would be the normal quantile plot that accompanies that. Obviously, that does not line up near a straight line So I don't think either of these would be disputable as far as what they're telling us. I will say there are cases where it is a little bit difficult to look at either the histogram or the normal quantile plot and make a definitive conclusion about it. So I will try to give you some that are very clearly one way or the other. There are hypothesis tests that we will get to in later, or we may get to, depending on our time, in later chapters that give us a definitive answer as to whether they are or are not normally distributed. Okay, if you're going to do this on your calculator, I have a list here of steps. First of all, you want to make sure you've entered your data in L1. You'll go to the stat plot, which is the second and y equals key. Make sure your graph is on, and you're going to select the last graph. Make sure you've entered wherever your data set is, whether it's L1 or L2. And don't forget to finish by doing zoom 9, and that's going to bring up your graph. So looking at this, I've kind of done screenshots here. The first one we've got is I've entered this data set in L1. So I'm going to go in and make sure that one plot is turned on. We don't want these others turned on because if they are, then it's going to give you an error message. So just one turned on. Over here, you want to make sure the sixth graph, this is the normal quantile plot. A lot of people want to confuse it with this first one. This is the scatter plot, and this is the normal quantile plot. They're very different graphs, so you want to choose this sixth one. Be sure that you put where your data is, and then do zoom 9 and look at your graph. So this one has a lot of curvature to it. It doesn't seem very close to a straight line. So we would say that that one is not a normally distributed population. Okay, if we were doing this on StatCrunch, if I look at StatCrunch, I would go to graph. If I already have my data entered, I would go to graph. And then this QQ plot, that is our normal quantile plot. So you'll choose the column that you want to work with. So in this case, I chose retention rate for this example and press compute. And you're going to see a graph that looks like this. So for the bulk of this graph, it does line up very close to a straight line. There's no systematic curvature to it. So you've got a few points off of it in the beginning and the end, but the most of it is along that straight line. So it would be normally distributed. Okay, so like we said, we can use our histogram and look for outliers as well. You can use your normal quantile plot, whether you construct that using a calculator or StatCrunch, you can construct that and identify whether it's normally distributed or not. Okay, so here's, I don't have the data in front of us, just trust me on this. It was 250 different eruption times for Old Faithful. And when I put that in, this is actually a screenshot from StatDisk. It's not one that we've worked with, but it is another software that's available to you, another statistical software. So StatDisk, if we look at this one, the histogram you can see is left-tailed. And you can also see on this that we get some curvature way off that straight line. So based on all of that, we would say that it is not normally distributed. Okay, so I have two data sets here that I would like for you to try, and then I'm going to go through and show you what you should have done. The first one is on shoe sizes. So if you'll pause this and make sure you have the data entered in your calculator, and then generate the normal quantile plot. So hopping over here to the calculator, I want to look at, first of all, if we put our data in, okay, put all of your shoe sizes in for L1. So I'm going to go, and first thing I'm going to do is I'm going to look at the histogram. So I want to make sure it's turned on, and then I want to choose the histogram, which is the third one, and do zoom 9. And you can see that this very much looks like it has a right skew to it. So if I go back and now look at the normal quantile plot, I'll do second y equals. And this time I'm going to choose the last graph. I'm going to do zoom number 9. And you can see that I do have some kind of curvature around that line. It's not lining up in a perfectly straight line. So that kind of shows us what it might look like there. Okay, so this is just kind of another look using the using the StatDisk. Okay, here's another set of data that I'd like for you to take a look at. So pause it, enter your data, and then we're going to look at what this would look like. Okay, for this one, I'm going to start out again with the histogram. So I'm going to do the histogram, and I'm going to do, in this case, my data is in L2, so I'm going to change that, and then I'm going to do zoom 9. Very clearly, this one has a skew to the right, even more so than the previous one we looked at. So when I look at the normal quantile plot, I'm going to go down to this last graph, and I've got my data set in L2, so zoom 9, and you can see this curvature that I get here. Okay, I'm going to pull up one here to use, and this is going to be the one that's normal quantile examples. You're going to be using the sample college data for the StatCrunch lab for this chapter. Okay, so this has the shoe sizes and the flight taxi. So these are the two data sets we just put in our calculator. If I want to do a normal quantile plot here, I'm going to go down to this QQ plot, and let's do shoe size and compute. And so there is that example, the normal quantile plot for the first data set for shoe size. And if I wanted to do the same thing for the flight taxi out times, compute that one, and you can see that we get nice data sets as well doing it that way. So I really like and the idea of you being proficient in the calculator use as well as StatCrunch. Realistically, in a business setting, you're probably going to be using some type of statistical software more than you're going to be using the calculator. So it's good to have experience with both. Okay, so this is just another comparison of the two showing the histogram and the normal quantile plot together there, and they clearly show that that would not be a normally distributed population. Okay, so today's video was pretty short and pretty straightforward. That takes us to the conclusion of Chapter 6